Hey everyone, it's time for some 8.3. We're going to start looking at vectors in the next couple of sections. This section is all about geometrically defined vectors and some applications. So if vectors are new to you, we're going to just start from the ground up here, but it's a vector or a quantity that involves both a magnitude and a direction. So it's two things. Examples are like velocity or force or things like that. They're represented by a directed line segment, which we'll look at some examples. And then the key to not getting too confused with vectors is that the length of the vector actually represents the magnitude. So magnitude is like speed is an example of that. So when you think of the length of a vector, it's actually not distance, it's speed, right, or force. So as an example, let's take a look at an airplane, for example, traveling west at a speed of 420 miles per hour. Notice two things are given, a direction and a magnitude. So we can represent that in a directed line segment, something like this, that's west, right? So it's pointing to the west. So you always have a point and an arrow, and then the length of that vector is the speed. Okay, so there would be a vector, right? Now, what can you do with vectors? You can multiply them by scalars, and then you can add them, subtract them. So we'll look at some of the basics of that right now. So scalar multiplication means you're going to take a vector. Let's call our vector, for example, A, and we're going to multiply it by a scalar K. One note of notation, bold is usually used for vectors. So if you see something in bold, a variable in bold, that's notation for a vector. Okay, so here notice the A is bold face. Okay, so we're going to multiply that by K. And then if K is greater than 0, the direction is the same as the direction of A. If K is negative, the direction is opposite. So just look at some of these examples. Here's, let's say here's A right here, right? Notice what happens with negative A. It just is the same length, but reverses direction. 2A just means that the length is twice that of A, right? Half is half of A, and then negative 2/3 is opposite direction, 2/3 of the length of A, okay, or the magnitude of A. Some vector addition. So you start getting a couple of things happening. So we have our airplane flying west at 420, and then we have a wind blowing north at 45 miles per hour. The resultant vector is going to be the true course and the ground speed of that plane. So let's draw a picture of that. So again, we have our vector going west. There we go. And then let's do a different color for the wind. The wind is purple. Okay. The wind is going north. All right. And notice both of those are vectors heading in the correct direction and to scale, right? So this one is length of 420. This has a length of 45. Okay, so if the plane is trying to go 420 miles per hour to the west, but there's a wind blowing 45 miles per hour north, what's that true course of the plane, right? If the way you do that is you draw a parallelogram, or in this case, it would be a rectangle. Let's try that with yellow. So I would make a line here that kind of matches my 45 vector, and then make a line here, which matches my 420 vector. The true course is the diagonal of that rectangle, or in general, parallelogram. So it starts here, and it's actually going to be heading on that diagonal, like that. Okay, and then with trigonometry, you can figure out the magnitude and the direction of that resultant vector. All right, so that gives a basic idea of what vectors are. Here is the actual rule for the addition of vectors. It's called the parallelogram law. let's say we have A going that way and B going that way, then the resultant vector, which we're calling A plus B, right? So it's the addition of the two vectors, or the resultant vector will be the diagonal of that parallelogram, okay? So it feels a little weird because you're not really adding A and B together, but that's the definition of it, of A plus B. It's the diagonal of that parallelogram, right? And there's two ways to think of it. If the points are joined right here, right, and then the arrows go off in two different directions, then A plus B is going off with the point there and the arrow there. Notice that, okay? Or there's the tail to tip way. You can put the B here, and then the point of A goes on the arrow of B, right? And then it's the diagonal of those two, same direction. Okay, so there's two ways to think of it. Most of the time, we're going to put the points together and have the arrows going off in different directions, and then just the diagonal. How about subtraction? Well, subtraction is just addition of a negative, right? So here's a picture of subtraction where you have, okay, there's your A, and there's your B, okay, and there's that diagonal A plus B. Now think of A minus B as A plus a negative B. So I'm going to draw a negative B, right? And then I'm going to take A and add negative B. So it would be the diagonal of that parallelogram on the left side there, okay? So that's A minus B. Just got to think of it as addition of a negative, addition of a vector going in the opposite direction. Okay, let's get to some examples. Enough of the framework here. Okay, so we've got two forces of magnitude 16 and 5. All right, so let's start constructing this, right? And they have an angle between them of 60 degrees. So let's put the 16 going this way. All right. And then in a 60-degree angle, we have the 5. So that would be like that, right? Something like that. So 16 and 5 are those lengths, okay? And then the angle between them is 60 degrees. Sketch the resultant force and find its magnitude. Okay, so what you want to do is create a parallelogram. I like to use yellow or dotted lines, but on this iPad, yellow works pretty nice. This is the Notability app. Okay, so I just complete my parallelogram. That's kind of close. All right, and then my resultant force is the diagonal of that parallelogram, starting at the point and going all the way to the other end of that parallelogram. Okay. And notice that what that does is you have a parallelogram, and then you have two triangles. So anything that's previous work to this, all of those things can be used to solve these triangles, right? A lot of law of sines and law of cosines here. Okay, so one thing to know about parallelograms is that the angles in the parallelogram all add up to 360. And so if this angle over here is 60, this one over here is going to be 180 minus 60, right? So that pair adds up to 180, and then this pair up here adds up to 180. Okay, so I'm going to do, to figure out that angle down there, which I'll need, I'm going to do 180 minus 60, 120. So this angle right here is 120 degrees. Okay, and if this is 5 over here, then it would be 5 on that side as well. So I can label that 5, right? And then let's call this green vector V, just to give it a name. Call it whatever you want, but I'm going to give it a name of V, bold V. And what I want to do to find the magnitude of V is find the length of that vector. And to do that, I have this triangle here, right? This bottom triangle, that one, right? And it's side, angle, side, right? So side, angle, side is law of cosines. So use your law of cosines formula. Man, let's go back to our standard blue. I want the magnitude of V. Okay. When you see this, these like, it looks like absolute value, that means magnitude. Okay, so what I just wrote there is the magnitude of V, and then the formula is squared. You know, what I'm using is the law of cosines. A squared equals B squared plus C squared minus 2AC cosine A. I'm just using that, but using the notation that fits this picture. So my A is actually the magnitude of V. So V squared equals the B and the C are the numbers that are given, right? So 16 squared plus 5 squared minus 2 times, oops, that should have been a B right there, huh? Sorry about that, BC. 16 times 5, those always match, and then cosine of the angle between. All right. Okay. In order to solve that, I'm going to calculate all of that. So V, magnitude of V squared. When I calculate all of this, I'm getting 361 exactly. Ooh. Okay. And then the magnitude of V would be the square root of 361, which actually works out to be 19. And that will be in pounds, the 19-pound force. All right. Okay, so let's take a break there. I'll pause and then I'll come back and do some more in the next video. Okay, off we go. Talk to you later.